And so we were in the middle of talking about the 5 ways to solve limits, and we stopped at number 4, trig limits, and now that's where we're going to pick back up right now. So for the trig limits, there's just 2 rules you need to know. If you have the limit as x approaches 0 of sine of x over x, the limit as x approaches 0, sine of x over x is equal to 1. That is just something that is true. It is as true as 2 plus 2 equals 4, and there is a proof to prove that this limit is 1, but it's really not important, and you don't need to know how it's 1 or why it comes out to be 1. Just know that it's equal to 1. And another thing, actually, if you were to do the reciprocal, limit as x approaches 0 of x over sine x, that would also be 1. So just a fun thing to know. But one thing that's super important is that limit has to be as x approaches 0. It has to. And the second trig limit that you need to know is the limit as x approaches 0 of 1 minus cosine x over x. That's going to be equal to 0. Again, these are just things you need to memorize, you need to know, especially if you start doing practice problems in class about it. The other way you can also write this one, the cosine x one, limit as x approaches 0 of cosine of x minus 1 over x, that is also equal to 0. And if you want to think about why, the reason is, this one I actually can explain, 1 minus cosine x is really just equal to negative cosine x minus 1. Do you agree with that? Well, I don't really care if you would agree with it. I mean, it's true. If you were to distribute out the negative, you would get that. And because of that negative sign, it's really like saying negative 1. And if you were to think about how the limit computes, it would be like saying, what's negative 1 times 0? Since this limit is 0 and you're multiplying it by negative 1, it's still 0. And for that reason, you can write it both ways. Both ways will work. So those are the 2 trig limits. And now let me show you some potential problems of something that you could see related to the trig limits. Let's look at some problems. So here's a question. What's the limit as x approaches 0? What is the limit as x approaches 0 of sine of 2x over 2x? Okay, so remember the formula from trig limit says that limit of sine of x over x is equal to 1 when x approaches 0. So we already have the first condition, x is approaching 0 here, that's good. What about sine of 2x over 2x? Well, I will tell you this. It doesn't matter what x is in the sine of x. Here it's 2x. I want you to think of this. Have you ever done a u substitution before? A u substitution says, I'm going to say, let u is equal to 2x, okay? U is equal to 2x. So I'm going to replace, wherever I see 2x, I'm going to replace with u. And so what I get is the limit as, well, I'll say u approaches 0 now. Limit as u approaches 0 of sine of u divided by u. And now it looks just like the case where we had initially, sine of x over x equals 1, except I just replaced my x's with u's. And so in this case, this is equal to 1. And really the takeaway here, if you kind of got lost in what I'm saying, I'm telling you that if you have sine of 5x over 5x, or sine of 100x over 100x, the answer, the limit as x approaches 0, is going to be 1 in all of those cases, because the 5x and the 100x need to match in the numerator and the denominator. So that's how you'd solve that problem. Now let's look at another scenario. How about the limit as x approaches 0 of 1 minus cosine of 2x over just x? And now it's kind of tricky. So we're trying to get 1 minus cosine of x over x. Like if this were just x, we would already know the answer is 0. But since it's 2x in the numerator and just x in the denominator, it's not that easy. So pretty much we have to ask ourselves, is there a way we can get 2x in the denominator? Because if we did, then we could do that same u substitution thinking that we just need to get the 2x here to match the 2x here. So that's going to be our goal. And I will tell you, the strategy that we're going to use is we're going to multiply by 1. But not just any 1, we're going to multiply by 1 in the form of 2 over 2. 2 over 2 is 1, correct? I'm allowed to do this. But what we do next is very important. We're going to have the limit as x approaches 0 of, in the numerator, I'm just going to write this, 2 times the quantity 1 minus cosine of 2x. I'm not going to touch that. I'm not going to distribute it. I'm just going to leave it like that. In the denominator, I'm just going to have 2 times x. Now here's what I want you to take away. Now we have 2x matches 2x. In other words, this limit, the limit of this bit, that is equal to 0. And one of the cool things about limits, and maybe no one told you this yet, is that if you have a constant, which we have a constant, it's this 2 here. If we have a constant or a coefficient with a limit, we can actually pull it out in front and put it right there. So here's what this limit looks like now. It's equal to 2 times the limit as x approaches 0 of quantity 1 minus cosine 2x divided by 2x. And now remember, since this 2x matches that 2x, we can say this whole limit is equal to 0. And then we can say, what do we have? We have 2 times 0, which, as we all know, is just going to be 0, and that is the answer to our limit. So again, the strategy here was, since we didn't start out with this x matching that 2x, what we did was we multiplied by 2 over 2, and then that allowed us to get that 2x to match the 2x, and we just had a leftover 2 here that we were able to pull out in front, and since it was 2 times 0, it just happened to be 0. And next time we're going to talk about the fifth and final way to evaluate a limit by hand, and we'll see you then. My name is Dan the Tutor, and thank you for joining me.